If you throw a stone into Lake Victoria or watch a football sail through the air during a free kick, the path it follows is a parabola. Quadratic equations generate these curves. The unknown variable's highest power is always 2. Standard form uses constants a, b, and c. For example, in x squared minus x minus 12 equals 0, a is 1, b is -1, and c is -12. Organizing an equation into this specific arrangement, where the entire expression is set to 0, is the mandatory first step before you can begin any solving. To solve this by factorization, we need to find two numbers that perform a double duty. They must multiply to equal our c constant and add together to equal our b constant. We start by listing factors for our c constant, -12. Because the result is negative, our pair must include one positive and one negative number. We test these pairs against our b constant, -1. -6 plus 2 gives us -4. That's incorrect. But -4 plus 3 equals -1. This pair satisfies both rules. We can now rewrite the entire equation using these factors. Our complex expression becomes two simple binomials, x minus 4 and x plus 3. Factorization is a translation tool. It turns a difficult addition problem into a straightforward multiplication problem. Think of those two brackets as a team working toward a result. The zero product property tells us that if a team's multiplied output is 0, logic dictates that at least one of those individual factors must be 0. This allows us to split the problem into two simple paths. If x minus 4 is the 0, then x equals 4. If x plus 3 is the 0, then x equals -3. These algebraic solutions represent physical locations. On a graph, the roots are the exact points where the curve intersects the x-axis. Watch out for the zero trap. This property only works when the product is 0. If the equation equals 6, you cannot simply set the factors to 6. Two numbers multiplying to 6 could be 2 and 3, or 1 and 6. This shortcut breaks the math. Practice this now. Pause the video and solve x squared plus 7x plus 10 equals 0 using the product sum method we just covered. By finding where the equation equals 0, we identify the transition points of a system. These roots mark the landing zone where a projectile hits the ground, or the break-even point where a shop's production level finally covers its costs. For a Ugandan farmer's rectangular garden, the area is 20 square meters, with dimensions x plus 3 and x plus 2. We multiply these factors to equal 20, then expand. Resetting to 0 by subtracting 20 reveals two roots, 2 and -7. Because a physical garden cannot have a negative length, we discard the negative root. In the real world, only the positive solution of 2 is valid. While factorization is the fastest tool for equations with small integers, more complex numbers require the quadratic formula or completing the square. Use this table to decide which tool fits your specific problem. You can practice all three of these methods with interactive exercises at yaka.cc. Mastering factorization allows you to deconstruct complex models and turn abstract equations into practical blueprints for the real world.